Hello and welcome back. I couldn't quite get through this question in the last video, so we'll just do that now. We've got 120 yards of fencing to enclose a rectangular region. So we've got our little rectangular pasture, and we'll have some side lengths. We want to find the dimensions, so we want to find x and y that maximize the area. So again, the area of this rectangle is just going to be x times y. And it also asks, what is the maximum area? So we need to figure out what x and y are, and we have one. So what we're trying to maximize is the area. So let's again write that over here. So our area is just going to be x times y, and this is what we want to maximize. However, we have an additional constraint. We only have 120 yards of fencing. So that means that 120 yards has got to last us the entire perimeter of our rectangle. So the perimeter of a rectangle, well, there's going to be two side lengths that are x long. There's going to be two side lengths that are y long. So the perimeter is just going to be those two side lengths plus those two side lengths. And all of that has to add up to 120. So this gives us a relationship between x and y. So if I write this down, I can solve for instance, y here. So if I subtract 2x from both sides, I'll get 2y is equal to 120 minus 2x. And if I divide both sides by 2, I'll get y is equal to 60 minus x. Cool. So now I know that y is 60 minus x. I can rewrite my equation for the area as x times 60 minus x. And if I distribute, this begins to look more familiar. So this will be 60x minus x squared. But maybe I'll shift this around so that we'll have minus x squared plus 60x. And this begins to look like our quadratic functions. And we can find the here the maximum of the quadratic function. Again, our first value is negative, which means that our quadratic function is going to open down. So we do have a maximum. So the question is, what is that maximum? Well, the value here is going to be at the vertex. And again, where the vertex happens is going to be at negative b over 2a. So b here is 60, so this is going to be negative 60 divided by 2 times a. A is just negative 1. So 2 times, this will be negative 60 over 2 times negative 1 is negative 2. So that's 30. So this vertex, so this is going to be our value for x. But we know we have a formula for y as well. So y is just going to be 60 minus x, and 60 minus 30 is in fact 30 as well. So one interesting thing to notice is that, well, if we have a rectangle whose side lengths are 30 and 30, what we have is a square. And in fact, we know the area as well. So if this is going to be 30 yards and 30 yards, the area is going to be 30 times 30, which is 900 square yards. So the maximum area is going to be 900 yards squared. And just as an aside, this is always going to be the case. If we want to maximize the area of a region, of a rectangular region, the maximum will always be a square.